In this video, we will talk about negation of conditional statements. Let's begin with an example. Here we are given this conditional. If it snows, then school closes. We want to find the negation of this statement. So when writing the negation, we want to make sure the given statement is completely false. The negation of this one will be it snows and the hypothesis part happens, but the conclusion part does not happen. And school does not close. This is the negation. Here, this is the hypothesis. And this is the conclusion. To negate this statement, we have hypothesis happening, but the conclusion does not happen. So the conditional doesn't apply, and this is the negation of the conditional. Now to write in symbolic form, we can let this to be S, and we can let school closes to be C. So we have S implies C. Then the negation part, it snows, we have S. School does not close, and school does not close. We have and, not C. So from here we can see the negation of the conditional S implies C is simply S and not C. So that's what we have over here written a little bit formally. So we have negation of P implies Q, same as P and not Q. Next, let's do some example. Here we are given the conditional. If this month is January, then the next month is February. So in this case, we have J implies F. Now using this formula over here, the negation will be J and not F. And this we can write as J first. So this month is January, and, or we could use the word but, and the next month is not February. So the negation is this month is January, but the next month is not February. Let's look at the next example. Here we have if it snows, then it does not rain. So denoting this by S, and it rains by R. So this is not R. If we let S to be it snows and R to be it rains, then we are given that S implies not R. So we want to find the negation. Negation will be P and not Q. For negation of P implies Q. So we have S and not the conclusion part. So not R. So this is same as S and R. This is the negation. And we can write it as it snows and R, it rains. So this is the negation. Let's look at the next example. It says if X is even, then X is divisible by 2. Again, if we let this part to be E and this part to be D, then we have E implies D. Using this formula again, we have the negation to be E and not D. So this we can write in the given form as X is even and X is not divisible by 2 because we have not D over here, not divisible by 2. This is the negation of the statement. If X is even, then X is divisible by 2. Let's look at the next example. If n is prime, then n is odd or n is 2. Let's denote this part by P, this part by O, and n is 2 by T. So in this case, we have P implies O or T. So we have P implies O or T. This is what we are given, and we want to negate this. To negate this, we have P and not Q. Our Q is this whole thing, O or T. Then it will look like P and not O or T, because Q in our case is O or T. Now I can apply De Morgan's law over here and write that as P and not O and not T. This thing. So if I want to sort of distribute not, then the or will flip and become and. And in the given format, I can write this as, so I basically have 3 statements combined by and. So this will become n is prime and n is not odd because we have not O, and n is not 2 because we have not T over here, not 2. Now in English, we don't like writing two ands like this. So instead of this one, I can just use comma. So n is prime, n is not odd, and n is not 2. This is the negation of the given statement. Let's look at the next example now. We have if n is divisible by 2 and n is divisible by 3, then n is divisible by 6. So I can consider the first part to be statement T, this part to be T. N is divisible by 3. Let's consider that part to be H and this to be S. So we have these 3 statements. In the symbolic form, I can write the given statement as T and H implies S. I can use parentheses over here. So using this formula, the negation will look like T and H and not S. So we have this as the negation using this statement. Our P in this case is T and H, and Q in this case is S. So we have T and H and not S. And if we write it in the form of the given statement, it will look like N is divisible by 2. We have and we have and H. N is divisible by 3. We have and not S. And N is not divisible by 6. Not divisible by 6. We have 3 ands. We have 3 statements connected by and. So we can just remove one of them and put a comma over here. N is divisible by 2. N is divisible by 3. And N is not divisible by 6. This is the negation of the given statement. Okay, now let's look at how we can prove the formula that we just used. So first we want to determine if these two are equivalent. P implies Q and not P or Q. So to decide that, we can use a truth table. We have P here, Q here, and we need not P for the truth table. And then we can have P implies Q, and we can have not P or Q. So we are going to compare this column and this column to decide if these two are equivalent. So we'll list all the possible combinations of truth values of P and Q. So we have true, true, false, false, true, false, true, false. Not P is simply the negation of P column. This will be false, false, true, true. P implies Q. True implies true is true. True implies false is false. And the other two, false implies true and false implies false. They are vacuously true. Now not P or Q. We have not P over here, this column, and Q this column. So we are combining those two by OR. True or false is true. False or false is false. True or true is true, and false or true is true. So we can see that these two are exactly the same. They are identical. So therefore, we can conclude that P implies Q is identical to not P or Q. So once we have that established, we can use that to find the negation of P implies Q. We have negation of P implies Q is same as negation of, so I can replace P implies Q by not P or Q. And then I can apply the De Morgan's law. That will give me not P and not Q. The first part, not P is simply P and not Q. So this is the formula.